This is the review for the 4 different operations of matrices. So just like regular numbers, there's these 4 main types of operations. You have addition, so adding 2 matrices, subtraction, multiplication, and there's actually 2 types of multiplications when it comes to matrices. You have scalar multiplication and dot multiplication, and I'll go through the difference between those in a few minutes. And then lastly, we have division. So I'm going to clear my screen here. We'll start with addition. We have addition. Okay, so when you're given 2 matrices, let's say this is your first matrix that's being added to a second matrix. First thing you want to do whenever you see some sort of operation between 2 matrices is you want to figure out the dimensions of each of the matrices. So for the first one, you want to look at the number of rows first, which are the ones going horizontally, and then you want to look at the number of columns. So you count those, so the number of rows go 1, 2. So your first dimension is 2 by 1 column, 2 column, 2. So your first matrix is a 2 by 2 matrix. So you do that same thing for the next one, 1 row, 2 row, 1 column, 2 column. The second one is also a 2 by 2 matrix. When you're adding, what you have to make sure is that these dimensions, the dimension of the first matrix matches the dimension of the second matrix. If they do match, then you can go on and you can add them. So you know that since you're adding, the dimension of your answer is the same as the dimensions for the other 2 matrices. So I always recommend putting the dimensions of your answer whenever you see an operation before you do anything further. So I'm just going to clear all this a little bit. It's a little simpler. Draw in the 4 spaces where your answers are going to go, just so it makes it more easier visually for you when you're going through it. So for addition, you want to look at the first row, first column of the first matrix, so that's a 2, and the first row, first column of the second matrix, so it's a 3, and you want to add them because we're adding these 2 matrices. So 2 plus 3 equals 5. So that's going to go in the first row, first column of your answer. Do that same thing with the next numbers. So you got first row, second column of the first one, which is 1. First row, second column of the second one, which is 1. 1 plus 1 equals 2. So that goes into the first row, second column of your answer. Do that for the next ones. -1 plus -2 is the same as -1 minus 2. So that's -3. And again, that's in the second row, first column. And then 3 plus 0 is 3. And that goes in row 2, column 2 of your answer. So the biggest thing for adding is just make sure that all of these dimensions add up or are the same, and make sure that you're staying in the same row and same column for when you're adding the numbers and when you're putting it into your answer matrix. Okay. So now we're going to move on to subtraction. And we're going to leave the same numbers there just to keep it easier. But we're just going to change that addition sign to a subtraction sign. Erase the circles around these. Okay, so just like addition, except it's not addition anymore, it's subtraction. Just like addition, you want to make sure that all of these dimensions are the same. In order to subtract, you have to make sure that the dimensions of your 2 matrices are identical. Draw in your answer matrix and put in the dashed lines for your answers, and then start in the first number, first row, first column, just like addition. Then you're going to look at the first row, first column of the second matrix, and you're going to go 2 minus 3 equals -1. That goes in the first row, first column of your answer matrix. So notice that everything is in the same row and column for each matrix. That stays the same for addition and subtraction. Then go on to 1 and 1. 1 minus 1 equals 0. That stays there. -1 minus -2, double negative, so -1 plus 2 equals 1. 3 minus 0 equals 3. Again, biggest thing for subtraction, just like addition, is making sure that you're staying in the same row and the same column throughout the entire problem. And as I said, always draw out your answer matrix and figure out the dimensions before you proceed, because it makes everything a lot easier. So now we're going to move on to the first type of multiplication. We have scalar multiplication. What scalar multiplication is you'll be given an array. Let's say it's 3, -2, 1, 0. Again, anytime you see an operation, you want to figure out the dimensions of this array. So you got 1 row, 2 rows, 1 column, 2 columns, so it's a 2 by 2 array. And there's going to be a number out front, and let's say that's 3. So you're multiplying this 3 by this matrix. That's scalar multiplication, is you're multiplying a number by a matrix. So in order to do that, again, always recommend writing out your answer matrix. For scalar multiplication, these two are going to be the same. So you're going to draw in the dashes there. You should have 4 answers. And all you're going to do is you're going to take the 3 that's out front here, and you're going to distribute it out to each number inside the matrix. So let me just show you what I mean. Erase those arrows just to keep it simple. We're going to do 3 times 3 to get 9. 3 times -2 to get -6. 3 times 1 to get 3. And then 3 times 0 to get 0. And that's how you do scalar multiplication. Biggest thing, just make sure, again, you're writing out your answer matrix before you go on with any calculations, just to know that you're getting the right number of answers. And then make sure that you're distributing the 3 out to every number inside the matrix and not just one number. So now we're going to go on to the second type of multiplication, which is dot multiplication. And this happens when you have 2 different matrices that are being multiplied by each other. So let's say you got -1, 3, 0, 2, and 2. First thing you always have to do whenever you have 2 matrices that are being multiplied to each other is, again, figure out the dimensions of the first one. Row 1, row 2, column 1, column 2. This is a 2 by 2. Rows are always first, and it's columns in the dimensions. So then you go to the second one, 1 row, 2 rows, 1 column, to 2 by 1. What you have to do is you have to check that the number of columns in the first matrix has to equal the number of rows in the second matrix. So the second number here has to equal the first number here. If those do, you can multiply them. If they don't, you cannot multiply them. So once you have that, you can figure out the dimensions of your answer matrix. So you cross those out, and you know that your answer is going to be a 2 by 1. You see you got the 2 here and the 1 here. That's how you figure out the dimensions for your answer matrix. Erase the lines through here. Again, draw in the little dashes for where your answers are going to go. You're going to have 2 answers for this. So what you want to do is you want to, it's kind of like crisscross multiplication. So you want your first answer here that you're looking for. So that's row 1, column 1 of your answer matrix. And this is why it makes it easier to draw it out before doing any calculations. So row 1, column 1 of your answer matrix, you want to look at row 1, column 1. Row 1 for the first matrix, column 1 for the second matrix. And then you want to multiply them. So you multiply -1 times -2, and you get 2. And then you multiply 3 times 1, and you get 3, and you add them. So it's multiply, multiply, add. You get 5. Okay? So we know that our first answer is 5. We do the same thing for the next answer. We're looking for the answer in, row 2, column 1. So we go down to row 2 for the first matrix, column 1 for the second matrix, and we do 0 times -2 and 2 times 1. So 0 times -2 is 0. 2 times 1 is 2, and then we add them. We find that our answer matrix is 5, 2. Biggest thing for dot multiplication is making sure that this dimension matches up with this dimension. Always write out your answer matrix before doing any calculations, and then know how you're supposed to do the crisscross when you're multiplying. So know that it's this number times this number. So it's the first number in the row of the first matrix. Remember, this is the row, times the first number in the column of the second matrix. And then it's the second number in the row times the second number in the column. Okay. We're going to move on to the last one, which is division. Now, the weird thing about division with matrices, let me draw it out here first. -2. The weird thing about division is that there is no division. Whenever you were given something like this, let's say it's 5 divided by 5 equals 1. That could be rewritten. Remember, keep, change, flip. So it's 5 times 1/5 equals 1. And all you're doing when you're flipping this 5 is you're multiplying. Remember, we changed the division sign to multiplication by its inverse. So multiplying by an inverse is the same as dividing by the original number. So we're going to use that same idea for matrices. So instead of dividing, you have to multiply the first matrix, so this is your first matrix, by the inverse of the second matrix. And there's another video just showing how to do the steps for finding an inverse. So I'm just going to go through that quick here. So for our inverse, we're going to flip the first and fourth term or switch them. So it's going to be 2, 3. Negate the second and third term. So it's -5, -1. Change our division sign to multiplication sign. Bring down our other matrix. And then our third step for trying to find the inverse for our second matrix is we need to find the determinant of the original matrix. Okay, so we're looking up here. So we look at the major diagonal, which is 6, look at the minor diagonal, which is 5, and then we subtract them. 6 minus 5 equals 1. When I say major diagonal, all I mean is you start in the top left and you end in the bottom right. And when I say minor, you start in the bottom left and you end in the top right. There's another video just showing how to do determinants if you want to go check that out. So then you divide each of these numbers by the determinant. And this is the inverse of this. So now we can proceed, and all we have to do is the same steps that we did for our dot multiplication before. That's all we have to do with these. So remember, whenever you're dot multiplying, you want to figure out the dimensions. So this is 2 by 2. So 2 by 2. These match up. This matches with this, so they can cross out. We know our answer matrix is going to be a 2 by 2. Fill in the blanks here. Okay. So now we got row 1, column 1, row 1, column 1. So we're going to do -2 times 2 is -4. 1 times -1 is -1. So -4 minus 1 equals -5. Row 1, column 2 for our next answer. So row 1, column 2. Oh, sorry. -2 times -5 equals 10. And then we're adding that to 1 times 3 equals 3 equals 13. And just for when we're doing these calculations, I left the determinant in the denominator, and you should do that too. It's not always going to be 1, so you can't just leave it out like that, and it makes it easier if you leave it in for doing your calculations. So then we're looking at row 2, column 1 for this answer, row 2, column 1. So 3 times 2 is 6, plus 1 times -1 is -1, so 6 minus 1 equals 5. This one is 5. And then we look at row 2, column 2, row 2, column 2. 3 times -5 is -15. 1 times 3 is 3. So -15 plus 3 equals -12. That's how we figure out the division for 2 matrices. The biggest thing is making sure that you remember that there is no division between matrices. You have to multiply by the inverse, just like you did with ordinary numbers. And you follow the same procedure for dot multiplication. So you make sure that these dimensions line up in order to be able to do it. Remember your steps for finding the matrix. There's another video on that, just to refresh yourself. And then, yeah, you just multiply the inverse by the original matrix, and that's how you find your answer.